Hello and welcome back. And we're here with Luca Maraschi. So, Luca has a great enthusiasm for a tech industry, something that started when he was just 6 years old when he started coding. It's something that I've been privileged to witness when I've watched his various talks in NodeConf over the years, right back to 2015, which was my first NodeConf, when he was speaking about the magic dump, which was all about the perils of fixing live bugs at 3 a.m. Um, we've had a lot of late night chats about cloud architectures and some very animated conversations about software architecture. In fact, just now we were talking backstage about open source and the importance of it in building the tech industry going forward. So, I'm going to pass you over to Luca, who's going to talk from mess to mesh using Fastify.
Thanks, Katie. It's always a pleasure to be introduced by you and to be here at this fantastic conference. I've been here for a few years and I can say it's still my favorite. So today we are gonna go again through a journey, right? I'm very famous for these stories, for these tales, for this nice walk through some personal experience. And this one is the metamorphosis of digital platform. And we're gonna do it from the mess to the mesh using Fastify, my favorite library. And I want actually to start recognizing the great success and the great work that the whole Fastify team is putting every single day in making this library a top-notch library. And I want to say it in Italian, and I want to say grazie to everyone. Let me introduce myself. I am Luca. Perfect pronunciation of my last name, Katie. My name is Luca Maraschi. I'm the VP of Engineering at CTO.ai here in today rainy Vancouver, but usually sunny. And I before joining CTO.ai, I was chief architect at Talos Digital. And so I've been through a lot of experiences in digital transformation and API transformation. And but you probably came to one of my talks, and you know that I can't avoid talking about food because I'm Italian, because I love food. And today I want to talk about one of my favorite simple but yet super difficult to get right Italian dishes, that is the cacio e pepe. And this one is the risotto made by Massimo Bottura. And it's very interesting that I mentioned this theme because, and very important to me, because Massimo invented this plate. He revisited the famous bucatini cacio e pepe, typically from the Roman tradition, to basically rescue a lot of wheels that they got damaged from Parmigiano Reggiano. So, and this dish actually represent for me one of the key values that I hold on and I try to embrace every single day. That is, simplicity is the ultimate sophistication. I told you it's a very simple dish to make, right? But yet so complicated to get right. And so let me start this journey like my usual start. It all started with the monolith, and we all have been there, right? And so this monolith that I want to represent like the Russian dolls, the matryoshka. And why? Because there was a lot of encapsulation, right? Things that were like all nested inside of each other. They became sometimes hidden. You didn't know what was inside until you discovered the tiny small one, right? But it takes some time. So it's complicated. And then the next step in this transformation were microservices. You all heard my talks, what I think about it. But yet, I want to kind of tell a few of the challenges of microservices, right? So service discovery, a long time ago, Matteo Collin and I made a beautiful talk in Amsterdam about Console and service discovery, which actually leads us to service registration. How do we keep a perfect topology of our services, and how do we version them, right? Because clearly now you have a lot of microservices that they have dependencies between each other. And then the infamous auth-in, auth-z, authentication and authorization, right? That in microservices, what commonly we saw is that you use Express or any other node library, or if you use Java Spring Boot, It's basically a middleware or a library that you use. So every single service has to implement it. And then as more services are added to this system, observability becomes extremely important. And so we all heard about Zipkin, or it's underneath protocol that is Dapper or Jaeger or open tracing. And then the last but not least, one of my favorite uh, challenges, circuit breaking and resiliency, right? So how do we make this system fault tolerant? And so, because at the end of the day, if we take a 10,000 feet overview, we are basically building a distributed system, and such as the entropy is super high. So it becomes a very kind of complicated system to manage, to handle. And one of the main challenges there is determinism and coordination, right? Because, you know, with more microsystems we add to the overall system, the more complicated the coordination becomes. And so the main question has always been, and I witness it and I had to answer it. How can I be sure that every API is using our best practices? Because that's the challenge. You start to distribute your teams, especially in this crazy 2020, with the distributed teams and remote teams becoming at the core of businesses. How do I do that? And so this is what you get, right? So I didn't want to use the spaghetti because this one is the spaghetti code. So I didn't want to create a conflict of interest. But this is basically what's usually happening, right, in microservices. And I saw it with my own eyes, probably not so colorful because most of the time it becomes a huge traffic jam, right? Traffic coordination becomes impossible to manage and it becomes convoluted, congested. The main issue that I see every single time is that you have service A try to call the database of service B. And so what you usually implement is the so-called central API gateway, where basically you have the web traffic going through the gateway, which dispatches call and coordinate as a sort of enterprise service bus to all the services. And so this is the so-called north to south traffic. And, I'm going to give you some ingredients for this recipe, right? The first one is Kong. It's my favorite API gateway. I think there is nothing is as good as Kong. Check it out. Um, Kong is at the core of this picture. And but we are looking at north-south traffic. And so what about east-west? So the service to service, the traffic thing that I was telling you earlier on. Well, that one is the service mesh. That's why you're over here. We are going from the mesh to the mesh, right? So how does a service mesh usually look like, right? So you have a data plane, proxy, most of the time Envoy. Many years ago, going back to 2013, when I designed the first service mesh, I used Nginx. And as you heard, recently Nginx just announced their Nginx service mesh. But how it works is basically every single service communicates only with this local proxy, and the proxy acts as a trampoline. It basically reroutes traffic to another service, right? So the service they don't communicate with each other, they communicate to an intermediary proxy. Usually is HTTP or TCP. Sometimes there is mutual TLS. But the core point is that everything is coordinated centrally by a control plane, right? And policies and telemetry and many other functionalities, they are injected into these proxies. And I cannot say anything better than Kuma is the best service mesh in the market. That's it. I tried them all, but nothing is as good as Kuma. And why? Because Kuma, first of all, allows you to abstract the concept of the underlying infrastructure, right? So Kuma is like uh, um, a real proxy that helps to operate on different kind of infrastructures, both on-prem and on cloud. But most and foremost, they offer security and MTLS out of the box, traffic control, observability, service discovery, and something else. So let's take a little bit of a step back into the picture that we are starting to paint, right? So we have an outer ring that safeguards north to south traffic, Kong, we have an inner ring that safeguards this mesh. Kuma can support multi-mesh, but is not the point of this talk to explain how Kuma works. But check it out. And so we have the service-to-service communication done. We have the outer network. We have some responsibility there. Then we have our responsibilities that they go in. And believe me, it's not a matroshka, this one. And if you look at how the picture starts to paint, so what is really a service mesh? The service mesh is just an overlay network, right? Let's call it for what it is. A long time ago, Uber created something similar called Hyperbahn, that was an overlay network for having the ring pop instances to communicate between each other. But this service mesh concept actually acts on two layers, layer 4 and layer 7. So the pure network, or the cloud, and the cloud infrastructure, and the application layer. But there is still a gap, right? How do we put our application? Where do we put our application? I believe if there was an OSI layer 8 and 9, that would be the business logic and the developer experience, right? So let's try to dig a little bit deeper there. Like Fastify, no other word, the best web framework in the Node.js ecosystem. And now I'm going to tell you why and how it fits the mesh concept, right? So if you look at Fastify architecture, it's simple, elegant, sophisticated. We have a bootloader. Well, not really a bootloader, a loader, a VO. There are some primitives that allow extensibility. There are plugins, decorators, and hooks. And then there is the router, the best in class. Find my way. This is Fastify in a nutshell, right? And it's very important that we focus on this central part, plugins, decorators, and hook, because if we take a little bit of a step back in how a Fastify app usually works, is that you load plugins. A Vue is able to consistently and deterministically load the plugins with their own chain of dependencies and push them into the Fastify app. So then you have your servers.listen and your API is up and running. So if we look at how plugins, they are actually kind of structured and what kind of encapsulation they guarantee and they offer, it's actually extremely interesting. A plugin which derives from a base class that is a Fastify plugin can have nested dependencies, can be encapsulated, and this is deterministic. So the way and isolated. So the way a plugin can encapsulate dependencies is guaranteed to be consistent. And this is extremely important. If you look, we have a plugin with inside another plugin with another three dependencies, and this one are loaded consistently. So if we look at a monolith, how you'd build it, right? You just put all plugins inside of a single application. But the beauty of Fastify is that you can transform that monolith. So you can start with a low infrastructure footprint and complexity and move into microservices in no time. Why? Because you take your plugin, you move it outside, put it inside of an app, and this one will be a micro app, which will run your plugin functionality, right? And so if you look at a little bit further, right, in this picture, you see that actually we can enable extremely interesting functionalities thanks to the plugin architecture. So let's think about secret injection, right? The elephant in the room for anybody. How do we solve it, right? So if you look at Docker, it uses basically environment variable injection. And if you are using HashiCorp Vault, like you should, or for example, AWS KMS or GCP KMS, what happens is that you store their secrets and variables, and those are injected. And if you use .m, you can then push them through your Fastify application. But what gets very interesting is that these application can propagate these variables as options inside of the plugins. So, and this is beautiful, right? Because you are enabling this kind of very kind of interesting workflow, right? Where your Fastify apps become some sort of dispatcher. And so if we look at, for example, how usually you start a Fastify app, it gets even more interesting. I think Fastify CLI, you should use it. That's it. Go npm install Fastify CLI and, Fastify start, and you can load your plugin. Because this is the whole concept, right? What I told you before is that Fastify can become an application container. And now you can build this micro application that can be distributed, right? Extremely interesting, extremely elegant. if you look at usually how an application is designed, clearly you have routing, validation, business logic, the north south, and then you go in and you have all these non-functional requirements. Usually are middlewares in traditional applications, or sometimes they are plugins, and you can use hooks to kind of intercept the event chain between the Fastify loader and the request handler. But what gets very interesting, if we take a step back and go back to our friend Envoy and Kuma, is that most of these things that are coming out of the box using Kong and Kuma. You have authentication with Kong. You have logging and tracing that is propagated through the mesh, and then you can do outside. And so your Fastify application, your application starts to become smaller. And now you have functionalities that they need to be consistent, that can be centrally controlled by the control plane. And so service mesh allows you to basically have open policy agent for your policies, or OAuth 2.0 or OIDC and Jagger, right? Out of the box. Last thing to do in your application. But let's go take a step back into our primitives, right? What are the primitives of a service? Roots, validation, and business logic. And how do I make a deterministic service runner? Because that was the whole point, determinism, right? How can I guarantee consistency? How can I guarantee that my basic application is the same across all my different deployed APIs? And this is kind of draw a line, a demarcation line, as I love to call it, between developers and operators, right? Because developers want to develop fast and operators want to operate consistently. So let's look into Fastify autoload, right? Is and let's add a pinch of salt, right? And in this pinch of salt, the interesting piece is that if you basically start to load the dependencies, you can start to rethink about the application as some sort of operating system, right? So Fastify can then load, and we talked about hooks earlier on, can load dependencies that are coming from a centrally managed config. So we have this config with all our plugins, and then we can use autoload to load dependencies that are declared outside or inside our Fastify application. And this is actually started to get very interesting, because it means that I can have plugins and functionalities that are coming from different sources, right? Which means that I can start to encapsulate and isolate some kind of common pattern and practices, right? And distribute them as a way to consistently have functionalities across, for example, our scale organization, an enterprise, or even a startup, right? And this resemble of an operating system bootloader, and this is actually allowing us to consistently create a service topology, or like I love to call it, a generation. Imagine this kind of um, living system, right, that changes and continuously evolves. And so if you look now, our application, we have an abstraction on the infrastructure, Docker. The application becomes a runner, and then we have plugins that represent business functionalities. So basically APIs. And then we have all the non-functional requirements that are controlled by the service mesh. And this is actually some sort of magic, right, that can happen in combination with how configuration can be handled by Fastify. And so this is probably was one of the most interesting pieces, right? I can actually have configuration per plugin. As we said, they are encapsulated. I can have a global configuration, and I can have a globally immutable configuration. So I can have a configuration that comes from some sort of outer source, and one that is embedded within my runner. So this one is allowing us to kind of lower the footprint on developers to take care of non-functional requirements. And so this is the mission that somehow we are, pursuing at CTO.ai. We believe, and I believe, having built this platform, that the future is for what, as I call it, evolve a modern Heroku that lives for everyone on a mesh. And last year, I was chatting with Katie right about this federated cloud, a cloud that takes down all boundaries and becomes a universal cloud. And I believe that as more we are going to simplify our application runners, and thanks to Fastify, this is possible in a super elegant way. We will be able to create these really boxes where developers will be able to deliver extremely fast value to market, lowering the cost of experimentation, POCs, right, and delivering more value to our customer and to the market. So I am welcoming you and probably also encouraging you to join our CTO.ai community if you want to hear more about this mesh, this idea. We're going to open source it clearly, most of the pieces, but join our community to be kept always up to date. And I want to leave you with ciao. Thanks again to everyone.
Thank you so much, Luca. That was amazing. Got time for maybe one, maybe two questions. So I'm going to kick off straight away with, how does the plugin model implemented by Fastify differ to one provided by other frameworks such as Happy.js?
Oh yeah, so it's all about the determinism and the algorithm that is behind Avio. I think the magic there is mostly Avio, and that's why it differs. So that is the way the determinism and the encapsulation are guaranteed, and that's why all this kind of let's build a basic container that can be shared across. And reference those plugins is possible. So I call it actually this one a natural evolution of any service mesh.
Question for you. To migrate an application written with Express to Fastify, do you recommend to rewrite the code base or to use Express plugin? Could that be a good compromise?
Yeah, so Fastify 3 actually introduced this huge breakthrough, the possibility of using to embed Express applications within Fastify. I would actually say, and that's my favorite term, is the strangler pattern. You can actually take your existing Express application within Fastify, and you can already start to implement the model that I just showed, because your application will run inside of that context. And then you can start strangling application, separate the concern, right? Because most of the time are all middlewares. And you can take these middlewares, put them inside of, some functionalities that are coming out of the box from a service mesh or an API gateway, and then strangle more and more and more so that you can basically reduce the footprint of your application. So I would actually start with the strangler and then slowly rebuild based on also business value and business impact.
Yeah, I've got to say, I think my favorite pattern is the strangler pattern as well. Listen, there is another couple of questions, and what I'm going to say is we are out of time. So what I'll do is I'll ask Luca to maybe get in touch with you on Twitter or something, so that if you've got any questions that you want
Absolutely.
to ask him, please do just go ahead and ask, and he will answer them. So thank you very much again, Luca.